Here we'll find the total value of a continuous income stream. R of t is a rate, which gives the account's continuous revenue stream as a function of time in years. Typical units for this would be dollars per year, for example. And R of t is not a one-time payment. It's a rate of payment which can change with time. In this example, I'm going to show how a continuous stream could be compared to discrete payments that we had dealt with in the past. And then we can see why an integration is helpful here. 0 is going to be the starting time of the integration, and n will be the ending time in years. The total value integration does not include any interest accrued during the time period. It just gives the total amount of money that was deposited by the revenue stream. So in this example, the R of t is set to a constant 20,000, and the units of that, even though they're not shown here, the units here will be dollars per year. Okay, and we want to find the total amount, the total value that was inputted to the account over 20 years. So to do this, first let's compare to how this would have been calculated if we were just doing it with discrete payments. So let's say, for example, that I was going to show the payments made over a 20-year period. All this would be just a series of dots, and there would be 20 dots. And then if we want, we could represent them as vertical lines as well, because this would have been with discrete payments. And let's say it was just a one-time payment each year of $20,000. How would we add something up like this? Well, an easy formula for it would just be the number of payments times the payment amount. So what would it be? 20 payments times $20,000 per payment. But yet another way of writing that would be 20 years times $20,000 per year. Now let's just rearrange it. And we'll put it into a summation. We'll go from I equals 1 to 20, number of payments. We'll do $20,000 per year times delta t. Okay. And so what would our final answer be? $400,000. Now let's go back and see how this compares to the integral. What we're going to want to do in the calculus approach to this is to integrate the function r of t dt. So hopefully you can see the similarity here. We'll integrate from 0 to 20. Let's try it. First, I'll mark off my bounds of integration. We'll go from 0 to 20, and then we'll add up all the area under the curve. Now, what does this correspond to? It's called the total value, the total amount paid in to the account. So we'll set it up as I did on the other page using the formula. And this is total value. Put in the numbers. Get our antiderivative. It's $400,000. All right, now we just want to sketch a graph of that antiderivative, 20,000t. So naturally, it's going to be a sloped line starting at 0, because at time 0, you haven't contributed any money yet because no time had passed. Okay, there we go. $400,000 invested.